All right, so in this family, in this lesson, we're gonna go over the lever family of machines. Now, a lever is basically just a long, rigid bar that is able to rotate freely around a support, in this case, the pencil, which is called a fulcrum. Okay, the most common example that you see on a playground would be a seesaw or a teeter-totter. Right? Now there's 5 different terms I want to go over. Okay, so when we look at a lever, we're going to have our fulcrum, that's one of the terms. Okay, then we're going to apply a force somewhere to lift a load somewhere else. So where we apply the force, we call the effort force, and we label it F subscript E. Then, wherever the load is, we call the load force, whatever it is we're trying to lift. In this case, the load force is down because its weight is pulling it down. Then we have the effort arm. So that's the distance from the fulcrum, where your lever is rotating around, to your effort force. Okay, and we label it D, because it's a distance, subscript E. And that's our effort arm. Similarly, our load arm is from the fulcrum to the load force. All right, so 5 things I want you to know when labeling a lever: the fulcrum, the effort force, the load force, the effort arm, and the load arm. All right, now, we have different types of levers. We have 3 classes of levers. And the class will depend on where the fulcrum, the load, and the effort forces are. So in our first class lever, you have the fulcrum in between where the load force and the effort force are. The fulcrum is in the middle. All right, so here's an example. You're trying to lift something. So you take a plank, put some sort of rock or as a fulcrum, you apply the effort here, and it lifts the load here on opposite sides of the fulcrum. That's a first class lever. A second class lever is where you have the load force in the middle. So the load force is in between the effort force and the fulcrum. An example would be a wheelbarrow. So the fulcrum is over here at the end where the wheel is. The load force is over here where you put everything inside the barrel. Okay, and the effort force is at the end where you lift it. Okay, so this would be a second class lever where the load force is in the middle. Okay, so first class, we have the fulcrum in the middle. Second class, the load force is in the middle. And you might be able to guess the third class, the effort force is in the middle. All right, so there's an example. All right, you have your load force at the end of your fishing rod. All right, you have the fulcrum, and then you have the effort force. All right, so we're kind of going to test to see if we're understanding the first, second, and third classes. So for each example here, we're going to say what class it is. But before we do that, let's actually figure out where the fulcrum and the load force and the effort force actually are. So in the case of a teeter-totter, your fulcrum is right there in the middle. So there's your first clue. If the fulcrum's in the middle, right, you can have your load here. And this kid's pushing off the ground with an effort here. So with the fulcrum in the middle, this is a first class lever. All right, now the second one, right here at the end. That's where this whole thing is rotating about. So this is our fulcrum right there. Right? This is what we want to crush. So right here, right, these are being crushed or being used to crush our load. So that's where the load force is. Where are you applying the effort? Your hands are on the grips, applying the effort to close those grips. So in this case, we have the load force in the middle, so it's a second class lever. All right, next one. All right, so here we have someone applying a force with this hand, right? You're holding it with your top hand and applying the force here. So it's rotating about your top hand, and the force you're applying is with this hand. So your top hand is essentially your fulcrum, and your bottom hand will be your effort force. Right? The load force is the resistance in the water. So there's your load force. So having our effort force in the middle, this is a third class lever. Okay, now it's slightly different in this case. So in this case, you're rowing like this, where your oars or your paddles are actually going through these little hoops on the side of your canoe. So that's where they're actually rotating about. That's where your fulcrum is. Okay? And you're applying your effort force here. And again, your load force is the resistance in the water. So in this case, the fulcrum being in the middle, we have a first class. All right, second last example, right here is where everything is rotating about, the rotational axis, so to speak. Right, you're going to try pick something up here, so these are going to squeeze on your load, and your hands are right here applying the force. So in this case, you have the force, the effort force in the middle, which is a third class lever. Lastly, we have scissors. Right there is our rotational axis. Everything's moving around that point. So that's where our fulcrum is. This is where we're going to cut. So that's where our load is. And this is where our fingers are applying the effort. Okay, so with the fulcrum in the middle, that's our first class lever. Right, so here's a couple other examples. Here's a biomechanical system, or your arms. Let's say you're trying to lift something. The load force is here. Right, your fulcrum will be your elbow. And your muscles connecting right here supply your effort force. So in this case, your effort force is in the middle. Right, you have a third class lever. Now we've already done labs with pulleys. But a pulley is essentially a lever, right? Because we have something that's rotating about some axis right in the middle there, which would be your fulcrum. On one side we have a load, and on the other side we have an effort force. Right? So there would be your load arm, and there would be your effort arm. A pulley acts just like a lever. Similarly, you can say the same thing with a wheel and axle. Again, they rotate about some fulcrum, right? And you have both a load and an effort. And the same thing with gears, right? They rotate, and you'll have a place where you have a load and a place where you'll have an effort.